Hello and welcome to this session of inheritance in Python. Today we are going to talk about how inheritance is implemented in Python. Now what's in it for you, everyone? We are going to talk about the concept of inheritance, the types of inheritance which are applicable. So the different kind of inheritance which we are going to talk about are single level inheritance, multi-level, hierarchical and multiple inheritance, and we are going to support each concept with an example. Before we begin this session, I just want to highlight that inheritance is not a new concept in any of the programming languages. Just like in Python, this concept is applicable across multiple programming languages like Java, C++, etc. Now, what is inheritance? Inheritance provides the reusability of a code. It allows you to inherit what you have written in a particular class or a piece of code, and you don't need to rewrite it. You can inherit it. So that is the main purpose of inheritance. It is creating a new class that utilizes the properties and behavior of an existing class. So we will support this with an example. So if you take a look at the syntax, the sample syntax over here, you have a base class and you have certain attributes, functions associated with the base class. And then you have a derived class in which you extend, basically you inherit the base class and you inherit the properties of the base class. Now, the new class formed is called the derived class or the child class. You can call it anything, derived, child or subclass. And the existing class whose properties are inherited is known as the base class, parent or superclass. These are synonymous. So anywhere you hear that, okay, you're working on a child class or derived class, you can easily figure out that you're talking about a derived class. And whenever there is a reference to a parent or a superclass, it means we're talking about the base class, right? Now, with this concept, with this idea, let's move ahead and look at the different types of inheritance which are possible in Python. Now here we are trying to display pictographically, diagrammatically the different kinds of inheritance, and this will make understanding more clear. Now let's talk about first single level inheritance. You have a class A and you have a class B. So basically only till class B, only single level child is inheriting the attributes, the properties of class A. So that is what we call as single level inheritance. Multi-level is you have multiple level of inheritance. In, for example, class B here inherits class A properties and class C inherits class B properties. So ultimately you can see that the properties get trickled down till class C, right? So that is the example of a multi-level, right? Next is hierarchical, in which two classes are inheriting from a single class. Class B is also inheriting from class A and class C is also inheriting from class A. So both class B and class C are kind of siblings to the parent class A, right? Multiple inheritance, it means that a child class is inheriting properties from two parent classes. So in this example, the class C is inherited the properties of class A also and class B also. So we will be looking at these examples when we will be running in Python. Now let's take this example with a real world object, right? Let's first try to give you a view of how we are going to, what we want to explain in the inheritance with real world objects, right? Now here we are taking an example of a black and white TV and a color TV. Now single level inheritance. In this type of inheritance, there is only one single derived class from a single base class, as I mentioned earlier. So for example, you can assume there is a class called black and white TV And what are the attributes of a simple black and white TV? It has a regulator, it has a sound adjustment. Now, there is a child class called color TV which inherits the basic attributes. Of course, a color TV also has a regulator, a sound adjustment, but additionally on top of it, it also provides new features like color picture and cable connection. So now, what do you understand by this is that the child inherits the basic properties from the parent class, but it also adds on the new additional features. So the color TV does not need to rewrite or the functionality of a regulator and the sound adjustment. It has inherited it. Multi-level, very similar to single level, but now we are adding more features. So like in the previous example, color TV inherited the features of black and white TV. Now we move a step ahead. Now there is another classification, another advancement of Wi-Fi LED TV. So that has also inherited the features from color TV, right? So it's a multi-level inheritance. So just to reiterate, the black and white TV had channel regulator, dish antenna. The color TV added additional features of color picture quality and cable connection. And the Wi-Fi enabled TV added the new smart features to that TV, which it inherited from the color TV. Multiple inheritance. Now, in multiple inheritance, the derived class is inherited from more than one base class, right? So now, for example, over here, you have a class called Android, which is an Android operating system based class. And one is the Wi-Fi LED class, which has the Wi-Fi features of like sound, picture, Wi-Fi enablement. And if you combine all these features and bring it into another child class, that class is the Smart TV class, which has the features of Android and the features of Wi-Fi LED TV. And then you call it as a Smart TV. It has all the Android applications, it has the Wi-Fi features and etc. So this is the example of multiple inheritance, getting the best of all the parents. Hierarchical, if more than one class is inherited from the base class, right? So now if we just tweak our prior example and just rephrase it, what we are saying is now from the black and white TV you can also make a color TV, you can also make a smart TV, or you can also make a Wi-Fi LED TV, right? So there is no restriction as such. So basically the color TV is also inheriting the features of a black and white TV. Smart TV is also inheriting the features of a black and white TV, and the Wi-Fi LED TV also is inheriting the features from black and white TV. So it's a very typical example of a hierarchical inheritance. So now let's quickly look at the examples. Okay, so let's start off with a very simple single level inheritance. Let's make a class and create a function called speak and print something. Okay, now let's make another class. So what we did was we created a class called Homo sapiens, and now we are creating a class called man, which inherits the attributes of Homo sapiens, and we say create a function which is specific to man. So Homo sapiens has a function which called speak, and man has a function called talk. And let's print it. Now let's create an object of man. Now what does this signify? The man class is also inheriting whatever is there in Homo sapiens. So man can even talk and he can even speak, right? So what we are going to do is first we are going to execute the function speak. So the base class function got called speak, and it is printing Homo sapiens speaking. And also we can call the child function man talking. Okay, so if you see, this is the basic difference which we want to highlight, that just you have created the object only for the child class, not the parent. So now by making the object of the child class, you can invoke the parent class function as well as the child, because the child has inherited the parent features. Now let's take an example of multi-level. So we will continue from our previous example. We will create a class Homo sapiens, define an function speak, and print. Now we will make another class man. Now we are saying man can walk. So we are saying man walking. Now this is the third level. This is the multi-level man child, and we are saying that a man child can eat. So ultimately, the man child can speak, can walk, can eat. All three operations can be performed. So we are going to make an object of man child. And now Python will allow us invoke walk function, speak function, and eat function. So this is a typical example of multi-level hierarchy. Now moving to our next type of inheritance, which is the multiple inheritance, where the child is deriving attributes, properties from two parents. So we will now create a class called calculation1 in our example, and let's make a function sum, and it will return a calculation x plus y. Second, calculation2, and let's create operation subtraction, and it will return x minus y. Okay, now we will create the derived class, which is inheriting both calculation1 and calculation2, and let's create its own function called multiplication. Okay, so derived class now has a sum function, subtraction function, and multiplication. Okay, so let's create an object for derived, and now let's invoke the relevant functions. So sum 120, subtraction, it should say minus 40, and multiplication 1000. So if you see, it's different from multi-level, it's multiple. It means that the child class has inherited from two parents its relevant functions, right? And that's how we are able to call them in the derived class. Now let's take another type, hierarchical inheritance. Okay, so in hierarchical inheritance, let's go back to our example of first we have the black and white TV, and we will create a function called antenna. Print channels are telecasted through antenna. Then we will create color TV, and we will define its own function called cable connection, plus it has inherited the function called antenna from black and white TV. Here it is. Okay, now we are going to create another class called as Wi-Fi LED TV, which is also inheriting from black and white. Now in this we are defining Bluetooth tethering function. Okay, and let's make another smart TV. Okay, and then we are gonna you can watch Android applications on OTT platform, right? So this is the class of smart TV. Okay, so what we have done eventually over here is we have created a black and white TV. Color TV also inherits from black and white TV. Wi-Fi LED also inherits from black and white TV. Smart TV also inherits from black and white TV. Okay, now let's try to create the relevant objects. We will first create an object of color TV. Then we will create Wi-Fi LED TV, and then we will create smart TV. Okay, now we will have the relevant functions available to invoke. So all the children objects now will have an antenna function A1, A2 and A3. All three are having the antenna function, so we can just try to print it. Okay, and then we can invoke the relevant child functions A1, cable connection, Bluetooth tethering, and Android applications. So if you see, this is an example of hierarchy. You have color, Wi-Fi, LED, and smart TV all inheriting the black and white TV features and its own features. Okay. Now, along with this concept, let me just also introduce some relevant concepts which are applicable along with the inheritance concept, which will be helpful. I also want to show you the example of init function. Init function is a constructor in Python language, and it is called by default whenever you instantiate an object. So let me give you an example over here. So here you have a class person, and we are just defining the init function, the constructor. Okay, and we are just defining certain attributes, instantiating certain attributes in the person, first name and the last name. And another function which I am calling is the print name. And I'll print the name. It's a straightforward function. Okay, so what I'm doing is I am creating a child class now called as student, which is inherited the features, attributes of the person base class. And I'm also making a constructor for student. And from student, I am invoking the constructor of the person class, right? So now, if you see, I'm going to make an object of student and initialize it with the self, the first name and the last name. And eventually, the parent class init function is being called, first name and the last name. And this function def print name, it will print James Anderson, right? As I have already initiated the parameters. Okay, so if you see now, what have I done? I have the attribute values in the parent class are getting printed by invoking the constructor of the child class. So what happened when you invoke student? By default, this init function got invoked. The parameters of James and Anderson got passed. Then from person, you invoke the constructor init. And here now, the first name and last name got initialized and then it got printed. So this is the basic feature of a init function. Now, like the way I have called person dot init over here, I can also make a call to super. There is a keyword called super keyword. So let's just take an example of super keyword. Okay. Let me have my child class like the previous one, parent class, the person class. And I'll have to just make a change in my student class. In the init function, instead of parent dot init, I will call super dot init. This is the keyword super function, which will always invoke the parent class, gives you the handle to the parent class, and then you can invoke the relevant method. And the invocation methodology will be the same, and you can check the output. It's going to be the same, but it's that the syntax is different. There is another keyword which is available for you to invoke the parent. So you don't need to know the class of the parent. You can just make a call to the super. Now let's also take a look at another utility function called is subclass, right? So what we are going to do is we are going to create a function calculation 1, calculation 2. Okay, so we have created two classes, calculation 1, calculation 2, independent classes, no one inheriting each other. Now we are going to create a derived class. Now this is the example what we had done earlier, very similar to multiple inheritance. So we are just actually recreating a multiple inheritance example. Okay, so you have a derived class which has multiple inheritance from calculation 1 and calculation 2, summation, multiplication and divide. Relevant functions are there. Now we will check which class is a subclass of which one, right? So let's create an object of derived. Now what we want to print is that whether derived is a subclass of calculation 2, and it should return true. And let's see, another is calculation 1, a subclass of calculation 2, it should return false, right? Because these two are independent classes. So is subclass is another function which is available in Python, which helps you decide, you can check whether which is a derived class and which is not a derived class. Next, let's take an example of another function called isInstance. Okay, we will take the same set of functions, create an object of derived, and check whether the object D is of which is it of a instance of class derived or not. It's true. So instead of derived, if I make it as calculation 2, for example, now if I say C equal to calculation 1 and say C is instance of derived, it should say false. But if I say calculation 1, it should say true. And if I say calculation 2, should say false, because calculation class is an independent class. D is a derived class from calculation 1 and calculation 2. So basically D is instance of both calculation 1, calculation 2. So it will always return true. I hope you had a great learning session with these concepts, and I look forward to connecting with you guys in my next session. Thank you very much.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.